Yellowstone latest hydrothermal activity, supervolcano remote southwest corner events. This is from the latest Yellowstone Volcano Observatory, the Caldera Chronicles that come out every week, March 18, dated. Why are there hydrothermal areas in Yellowstone? Well, fundamentally, it's due to the presence of water from rain and snow, and heat from the magma, and suitable geology, that is, porous rocks. Water that percolates into the ground is heated indirectly by the underlying magma and migrates back to the surface along faults and at the terminations of volcanic flows. Volcanic gases travel to the surface alongside the water. The highest concentrations of thermal features are near the center of the park, for example, the upper geyser basin, where Old Faithful is located, and Norris Geyser Basin. However, there are over 10,000 thermal features scattered throughout the park, 10,000. And to get a full picture of Yellowstone's hydrothermal system, we're attempting to make a more complete accounting of water and gas chemistry of these features. This includes the remote southwest part of Yellowstone National Park in the vicinity of the Bachelor River and the Boundary Creek. The unnamed but charismatic thermal feature alongside Ferris Fork near the Bachelor River, the center of the pool roiling in gas bubbles but not boiling. The pool is only about 180 degrees Fahrenheit, that's 81 degrees Celsius, and all the gas is bubbling up from underground. The white color is due to the silica saturated water depositing sinter as it flows out and cools, while the red and green patches are cooler areas where algae mats are thriving. Now, they've been laying down infrastructure in Yellowstone's hydrothermal areas because of the heat. A lot of these areas where they had the boardwalks and pathways have been destroyed, either burned up or melted off. So when it comes to building and maintaining infrastructure in Yellowstone National Park, the dynamic character of the environment often requires creative thinking and adaptability, like the long-term monitoring equipment and the elements. Park infrastructure is in a running battle with a constantly changing hydrothermal system and geological landscape, but with enough data and foresight, Yellowstone's geology team and maintenance crews can make informed decisions on where to lay the new roads and the boardwalks and other facilities to make these structures lasting and useful and as safe as possible for the visitors. Now, let's go to the Yellowstone Caldera Chronicles to see what they've learned from this little visited area of Yellowstone. They're exploring their thermal areas in Yellowstone's remote southwest corner. Yellowstone Caldera Chronicles weekly column written by scientists, as we know, every week. Now, why are there hydrothermal areas in Yellowstone? Well, it's due to the presence of water, as we said, from the rain and the snow, heat from magma, suitable geology, the porous rocks, the water percolating into the ground, reheated indirectly by the underlying magma, and migrating back to the surface along faults and at the terminations of the volcanic flows. Volcanic gases travel to the surface alongside with the water, and the highest concentrations of thermal features are near the center of the park, at the upper geyser basin, where Old Faithful is located, and the Norris Geyser Basin, and as they said, over 10,000 thermal features scattered throughout the whole park. So to get a full picture of Yellowstone hydrothermal system, they are trying to make a more complete accounting of water and gas chemistry of these features. You can imagine how huge this whole area is, that they still, after all these years, have not taken into account all these thermal features. Now, for the last 2 years, scientists from the USGS and the National Park Service traveled to the southwest corner of the park to study remote thermal areas around Boundary Creek and the Bachelor River. They planned their trips by looking at visible and thermal infrared satellite imagery, and that revealed the locations of thermal areas. Even Google Earth is a great tool for exploring these regions, they said. And before they headed out to Yellowstone, they prepared equipment in the lab. Gas collection bottles were hooked up to a vacuum line to pump out all the air. so that they could get samples consisting solely of volcanic gases. They also packed clean plastic sample bottles and filters for collecting the water, and equipment for measuring water temperatures and stream flow rates. The thermal areas in the southwest corner of the park are quite remote, and to get there, they had to pack all of their equipment and supplies onto the mules, then hiked for long distances up to 13 miles from the road to set up base camp. On their work days, they carried equipment in backpacks and hiked a few more miles, mostly on trails, to sample the thermal areas. Equipment they needed to pack for the day might include, for example, up to 8 glass bottles and several pounds of tools, not to mention tubing, field books and GPS units, and other necessary equipment. Now, the features in the southwest corner consist of a mix of thermal waters and gases from the deep reservoirs and cooler waters with associated dissolved gases resulting from rain and surface water interacting with hot rock. Finding the ideal site for gas sampling could be tricky, they said. A pool with strong bubbling action is certainly releasing a lot of volcanic gas, but the gas can contain air and water. A site with steaming ground can be harder to identify, but the sample will likely contain more volcanic gas. Ideally, they said, we would sample gas from hot, vigorous fumaroles, but there are not many of them in this area, whereas bubbling pools are common. And then they said, we returned from Yellowstone, we analyzed the gases we collected. The gas discharging from the thermal areas is mostly steam, which is visible on a cold morning. Except for steam, more than 90% of the gas consists of carbon dioxide. The remainder of the gas is in the southwest corner of the park is mostly nitrogen. Most, but not all, of the CO2 originates in the magmatic system beneath Yellowstone, but most of the nitrogen has a different origin. When rainwater percolates into the ground, it contains dissolved air, including both nitrogen and oxygen. As groundwater flows through the hydrothermal systems, the oxygen reacts with the surrounding rock, while the nitrogen does not. And notably, the gases emitted in the southwest corner of the park contain very little hydrogen sulfide, H2S, unlike gas sources in some other active areas of Yellowstone. And they said, we will use the data we collected to improve the understanding of hydrothermal activity in Yellowstone's southwest corner. On this ongoing work, we are investigating whether the chemical compositions of gases and thermal waters are similar to those in other areas, and what these chemical compositions might tell us about the entire Yellowstone hydrothermal system. Now, talking about the hydrothermal and geothermal activity in Yellowstone, we've seen that the geysers are quite active, and one that has really woken up is, of course, the Steamboat geyser. It's erupted just about the Steamboat geyser experiencing relatively minor eruption, but since last March, it's been erupting as often as once a week. So something has changed there in its geological makeup. In 2018, Steamboat geyser entered a much more active period with 42 eruptions recorded between March 15, 2018 and up to just the day before, March 17, 2019, of which 32 occurred in 2018. So this broke the 1964 record of 29 for most recorded eruptions in a calendar year. So it is just erupting just about once a week, so that is totally different. I'll make a video with a new webcam of Yellowstone Old Faithful to see how it looks today, and just for you to enjoy for a few moments of enjoying something beautiful from Yellowstone. Thank you. If you'd like to join me on my Patreon account, You will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.